what you've done in geometry, because you did do sine, cosine, and tangent in geometry class. But if you don't remember this, then hopefully today will help you. So trigonometric functions of right angles, right triangles are really what we're looking for here. These are buttons that you've always seen on your calculator, and in geometry class you learn how to use them. If we pick one of these acute angles to be theta, it doesn't matter which one, but I think we should all pick the same one, so let's all pick this bottom one and call it theta. We can relate the angle to the side and write these trig functions out. So if this is theta, the side across from it we call the opposite side because it's opposite the angle. We all know that in a right triangle, the longest side is called the hypotenuse. And then this side, the side that's not opposite it, the side that's right next to it, is called the adjacent side because adjacent means right next to. And then we can relate this, and I don't know if you remember this from geometry or if you were taught this in geometry, but this is a way to remember these ratios. On your calculator it says, looks like sin, but it's not sin. It's actually sine, but we dropped the E because it won't fit on the button on your calculator. So we just write sin, but don't say sin. Sine is the side opposite over the side hypotenuse. So we would say opposite over hypotenuse, or that's where the so comes from. This is not cos or cos or whatever you want to say. This is cosine. And the cosine is always, of the angle, is adjacent over hypotenuse, or cosine adjacent over hypotenuse. And tan is actually tangent, and tangent is opposite over adjacent, or SOHCAHTOA. And so you need to know those ratios. Vague memories of this from geometry class? Something that you didn't learn in geometry class is that sine, cosine, and tangent have reciprocal functions. So there's 3 more trig functions that you haven't learned about until today. They're not buttons on your calculator for these. And the first one is cosecant, and we abbreviate it CSC, but when we see this, we say cosecant. And the great thing is, if you know sine, then you already know cosecant. Cosecant is just flipping it over. So instead of opposite over hypotenuse, cosecant is hypotenuse over opposite. And the reciprocal of cosine is secant. And if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And my whole life, I've always remembered these is somebody mislabeled them, because I always have thought that cosine should go with cosecant because they both start with co, but they don't. And then sine and secant, like I always felt like they should go like that. So in my mind, when I'm doing these, I always remember cosecant should go with cosine, but it doesn't. So I remember it goes with sine. That might have just confused you completely, but that's how I remember which is which. And that's the big thing. These are the ones people mix up. Tangent is the easy one. The reciprocal of tangent is cotangent. The reciprocal of sine can't be cosine because we already have cosine. And that's adjacent over opposite. So part of your homework today is just practicing using these 6 trig functions, using triangles, stuff that I know you didn't in algebra class, not algebra class, geometry class. But these are the new ones. Okay? So let's look at one with a lovely little triangle. Are you okay if I go? Alright, so it says find all 6 trig functions. And notice they give us a triangle, they give us which angle to use. And actually just one thing before I go on here. Just want to remind you that if theta was up here, that the side opposite changes. Do you agree with me on that? I never used to say this, and then I thought some people always assumed that this is always the opposite side, but it's where theta is. If theta was up here, do you agree that now this is opposite and this is adjacent? So you got to pay attention to where your angle is. So using Using this one, they give us a triangle. The hypotenuse is 13, one side is 5. We have to know all 3 sides of a triangle in order to do this. So how do I find the third side of this triangle if I don't know it? I mean, I don't know it. Sam? Something squares. Yeah, what's that called? What is that? Pythagorean theorem, right? Right triangles, Pythagorean theorem. We could say 5 squared plus something squared equals 13 squared. If this works out to a nice perfect square, that's great. If it doesn't, do not give me decimals. You're always going to use the square root because you want to give an exact answer, and a square root is not an exact answer. Simplify it if you can, but don't give me decimals on this. But this one I think works out really nice because you get 169 minus 25, which is 144, and the square root of 144 is 12. Not plus or minus 12 because we're talking about the side of a triangle, and the side of a triangle can't be negative. If you know all 3 sides, you're just going through and you're going to do sine, cosine, tangent, cosecant, secant, cotangent, and you're just going to write the ratios. Really important that you put the angle here. So you have to say sine of theta equals something, and I'll when I give you homework quizzes for the next while before we have a test, is I want to make sure I get that down. A lot of people just end up writing sine equals. Sine of what? Sometimes there's 2 different angles, and so you got to make sure you label which one. So sine of theta, sine is opposite over hypotenuse. You just write 5 over 13. And that's it. That's all you're doing right now. Cosine of theta, cosine is adjacent over hypotenuse, or that would be 12 over 13. And tangent of theta, tangent is opposite over adjacent, or 5 over 12. Anyone have a question of where I'm getting those values? Once I do sine, cosine, and tangent, I don't even look at the triangle anymore because I know that the reciprocals, I'm just going to flip each one of these over. Just make sure you put the right one with the right function. So sine's reciprocal is cosecant. And if sine is 5 over 13, cosecant is 13 over 5. The reciprocal of cosine is secant. So cosine is 12 over 13. Secant is 13 over 12. And cotangent is 12 over 5 because it's reciprocal of that. Not so bad. Questions about any of that? Sometimes I like to mix it up a little bit. Instead of giving you a picture, sometimes they might give you one trig function and ask you to find the other one. So let's make sure we can do that really quick before we look at the other thing we're doing today. So let's find the other 5 trig functions if sine of theta equals 2 over 3. What do we know if sine of theta equals 2 over 3? Yeah, if they give you any trig function, they're giving you 2 of the 3 sides. The only difference is they didn't draw the picture for you, so you can make your own picture. Does it matter which angle I call theta? It really doesn't, as long as you label it correctly. So if I call this theta, you have to make sure that the opposite side is 2 and the hypotenuse is 3. But it's not wrong if you draw, that's a lovely triangle. If you call this angle theta, the opposite side would be 2 and the hypotenuse would be 3. Am I still going to get the same value over here when I do Pythagorean theorem? It doesn't matter which angle you call theta. It matters that the side opposite it is labeled as 2. So just be aware that both of those are correct when you do that. Now this one doesn't work out so nicely. When you do this, you get 3 squared 2 squared plus x squared, or 9 minus 4. So you get that adjacent side is the square root of 5. If you put decimals on these trig values, you won't get points for that. So make sure you leave them as radicals. The other thing that comes into play if we have radicals, remember that we don't want radicals in the bottom of our fraction. So if we end up with a radical on the bottom, we got to rationalize that. And pretty soon you're going to do that without even thinking, because we're going to see it so often. Anyone have a question about how I found that? Courtney.
This is a really dumb question, but point 3 is that line always going to be like the next one?
Always.
So the only thing that's going to change is the adjacent and opposite.
Depending on which angle you label it, yes. But when you find sine, cosine, tangent, no matter which picture you look at, it's still going to be the same. Like if I look at, we already have sine, but let's say if we looked at cosine of this, using this picture, cosine is adjacent over hypotenuse, which is going to be the square root of 5 over 3. Which is the exact same thing you get over here, adjacent over hypotenuse, depending on where theta is. Other questions about that? Tangent is opposite over adjacent, so you get 2 over the square root of 5. And what do we do to get that square root of 5 on the bottom? Which is not as hard as addition, subtraction, conjugate stuff. What can you multiply the square root of 5 by that makes it a perfect square? The square root of 5. You can just multiply the top and the bottom by the square root of 5, and that becomes 2 square root of 5 over 5. And if you can do that without showing that step, I'm totally okay with it, because you're going to end up realizing that every time you're just moving that up, and the bottom becomes not as perfect square. So that's your tangent. And then I'm just going to flip them over. What's the reciprocal of sine again? Cosecant. And I'm going to flip it over and get 3 over 2. And the reciprocal of cosine is secant. So I'm going to get 3 over the square root of 5. And I got to rationalize that and get 3 square root of 5 over 5. And cotangent, I just want you to think about this. A lot of times people take this answer and they flip it over and then they got to simplify it and it's really ugly. But you could make this a lot easier on yourself. This was our original answer. Could we just flip that over and then the square root to the top instead of the bottom? That's what I do. So I say, well, I'm not going to use that. Go back to this. That's the square root of 5 over 2, and now I don't have to rationalize it. The other thing that we want to get into is talking about these special angles, and the unit circle and special triangles are our other big thing that we want to do. So let's see if we can at least draw these special triangles today. I'm going to skip the There are 2 special triangles that you learned about in geometry, but you might have forgotten them. They are a 30-degree, 60-degree, 90-degree triangle. Or you can use those as the radians as well. We could convert them. And the other special triangle is an isosceles right triangle, which means the sides are the same, which means the angles are the same. So that's a 45, 45, 90 triangle. And in geometry, you learn that the ratio of these sides are always the same, depending on what one side is. For trig, we always use a radius of 1. So we can actually plug numbers in here, not x values. And if you memorize these 2 triangles, you know a whole lot of trig. So I'm not expecting that they're memorized by tomorrow, but I'm just expecting that you maybe kind of look at them. There's some on your homework today that say evaluate these without a calculator, which means they want you to use these special angles to find sine, cosine, or tangent. So in a 30, 60, 90 triangle, the shortest side, which is the side across from the smallest angle, is always going to be 1. For us. And the hypotenuse is always double that, so it's always 2. And the other side, that's the middle side, is the shortest side times the square root of 3, or 1 times the square root of 3 is just the square root of 3. And if you know that ratio, that a 30, 60, 90 triangle is 1, 2 square root of 3, you can do almost everything that we do in trig using these angles. Okay? The other one is a 45, 45, 90 triangle, and the sides are the same. It's isosceles, and again, we're talking about a unit circle here, so the radius is always 1. So 1, 1, and then think about if you did the Pythagorean theorem here, that's going to end up being the square root of 2. 1, 1 square root of 2. So on your homework today, you're going to see some questions that say, do this without a calculator. That means I shouldn't have decimals, and it means they want you to use these two triangles. They have them in radians, so maybe let's just write out real quick these in radians. 30 degrees in radians is pi over 6. 60 degrees in radians is pi over 3, which you could do these conversions yourself, but I'm just helping you out here. And 45 degrees is pi over 4. So on your homework today, without a calculator, use these. And if you have these right in front of you, all you're doing is looking at what angle they say. If they say find the sine of 30 degrees, you would say 30 degrees is opposite over hypotenuse. So the sine of 30 degrees is 1/2. Agree with me on that? So just be aware that that's what you're doing. And then there's other part of your homework that actually wants you to use a calculator. So if you don't have a calculator, I'm going to grab some, because on your test, there are going to be times that I ask you to use a calculator, and you got to make sure that you know how to do it. So let's have a little calculator lesson today. Who needs a calculator? I'm PE teacher today, so I'm on the go. Okay, so these are ones that they say use a calculator, and the very first thing that you need to learn about when we're using a calculator is sometimes they ask you to find something in degrees, and sometimes they ask you to find it in radians. How do we know it's a radian and not a degree? It doesn't have a degree symbol. All right, so when you turn on your calculator can be in degree mode or it can be in radian mode. Most calculators are automatically in degree mode. So step one is you want to find on your calculator if it has a D. On my calculator, it has DEG at the bottom of it in degrees. If it's in radians, it says RAD. Anybody need help finding that on your calculator? No. Is everybody in degrees already? So you always want to make sure what mode you're in. I can tell you that every year that I've taught precalculus, there are people that miss points because their calculator's in the wrong mode. And so you have to make sure you're in the right mode. And if you're in degree mode, most calculators, you just hit the sign button, you type in 16.35, and it gives you the answer. Some calculators, you have to hit this and then sign, but most calculators aren't like that anymore. So let's just type it in our calculator, go to 4 decimal places to make sure that we would get the same answer. 0.2815 would be 4 decimal places. Anyone have questions about that? Now to go to radian mode, in my calculator, it's just right next to the second button. There's a DRG button, and that stands for degrees, radians, and grade, or I don't even know what the G is. I've never used it my whole life, so I have no idea. But if you hit that button on mine, it just says degree, radian, whatever. And if you want to go to radians, you go over to that, and you should see that now it's changed to RAD at the bottom, or it just has an R depending on your calculator. Anybody need help looking at the calculator if it changes radians? And I kind of picked a hard one here because maybe we aren't ready for cosecant yet. But for radians, you would just type it in. Except for the reciprocal functions, there is not a button on your calculator for secant, cosecant, and cotangent because you don't need a button. Think about if the sine, let's do cosecant. If the cosecant of an angle is 3, we know that the sine of that angle would be what? 1/3. Alright, so we're allowed to just flip this over. But the difference is over here, you can't just take the sine of 1/3 because that's the answer part. But what you can do is if you see cosecant of 3, you can say then that's just the reciprocal of 1 over the sine of 3. So that's why there's not a cosecant, a secant, and a cotangent button, because you don't need it. You can just take 1 divided by that. So 1 divided by the sine of 3 radians will give you the cosecant of 3 radians. So in radian mode, you'd hit 1 divided by sine of 3, and you should get like 7 point something, 7.0862 if I'm going to 4 decimal places. Did you get that? Because there's no degree sign, right? See how there's like a degree next to 3? That's how you know. All right, here. So I hit shift and this. See where it says degree, radian, radian. So you hit 4. Just got like R up there now. Anybody not get this or need help with this? Well, just because when we wrote out we wrote out that sine is opposite over hypotenuse, and so if cosecant is 3, that'd be like 3 over 1, right? That's totally different than this problem over here. But that's just, the definition of cosecant and sine is the reciprocals of each other. Does that make sense? Yeah. And so, when you're doing it on your calculator, you have to do it like this, though, and we'll talk about that a lot more. But there are questions on your homework with calculators. Make sure you leave mine in here, but if you don't have a calculator at home, come in tomorrow, and the first thing you should do is grab this. If you have a cell phone, like a smartphone, there's a calculator on that, and like mine, if you turn it sideways, it changes to a scientific, and there's a sine, a cosine, and a tangent button on there. You can also, on your computer, under accessories, there's a calculator that's scientific that has sine, cosine, and tangent. Or if you just Google free online calculator, you could get one on there if you don't own one that has those buttons on it. But we're going to be using calculators a lot, so if you don't have one, you can buy one between $10 and $12. It really would be a good investment, just because we're going to use it a lot. Here's your homework. 3 through 18 multiples of 3, 19 through 24 all, and 30 through 40 even. I'll tell you, 19 through 24 are the ones that you're using those special triangles that we drew in our notes. So they're all 30 degrees, 60 degrees, or 45 degrees, and all you got to do is look at those triangles to find the answers. They shouldn't be hard work. Some of the other ones you have to write like all 6 trig functions.